My talk is on logical and causal inference, truth, counterfactual scope, and invariance. So, where is the... Okay, in his webpage, Zena Tavares, whose webpage I looked at before this conference, says, I want to understand how humans reason, how they come to derive knowledge from observing and interacting with the world. And this is also what I want to understand. And in this talk, I will pursue this interest by examining two types of inference that are often thought to be very different from each other: logical inference and causal inference. Logical inference allegedly has nothing to do with the world. Causal inference has everything to do with the world. I will examine the nature of these inferences by using three parameters. One, truth, in the strong sense of factual truth or truth in the world, not linguistic truth, or coherentist truth, or pragmatist truth, and counterfactual scope and invariance. My result will be, one, contrary to expectations, logical and causal inferences are similar with respect to truth in the world. Two, they are different with respect to counterfactual scope and invariance, but only in degree. Truth. Logic is usually thought to have nothing to do with the world, hence with truth in the world. Logic is said to be analytic, i.e., based on language or meaning, regardless of how the world happens to be or necessarily is. The logical inference, and here I use same kind of inference as Alex, one, PA or PB, not PA, therefore PB, is of the same kind as the linguistic inference, A is a bachelor, therefore A is unmarried, and different in kind from Hume's relevant example of a causal inference, A hit B, therefore B moved, where A and B are, say, billiard balls. Now, inference 3, A hit B, therefore B moves, depends on the way the world is, on a certain regularity in the world, as Hume said, a connection in the world between two events. But the common view is 1 and 2 don't depend on the way the world is. They don't depend on any regularity in the world. They depend on the way our language is, on the meaning of words, and a conventional connection between words in our language, Carnap, or on the language game we happen to be playing, Wittgenstein. Now, all three inferences, the logical, the linguistic, and the causal, guarantee the transmission of truth from the premises to conclusion. That's why they are inferences. Indeed, they guarantee the transmission of truth in the world from premises to conclusion. Assuming the premises are true in the world, the conclusion is guaranteed to be true in the world. But while the transmission of truth in the causal inference is due to a connection between things or event in the world, the transmission of truth in the linguistic inference is due to a connection between words in our language, bachelor and unmarried. And the view is the transmission of truth in the logical inference is also thought to be true due to a connection between words. On this view, the correctness of A is a bachelor, therefore A is unmarried, is due to a connection between its non-logical words, bachelor, and unmarried. And the correctness of the logical inference, PA or PB, not PA, therefore PB, is due to a connection between its logical words, or and not. But does this mean that one is grounded only or mainly in language? The sentences in the inference, in the logical inference, say something about the world. The first premise says that in the world, at least one of the two individuals, A and B, is in P or has the property P. The second premise says that in the world, A is in the complement of P. And the conclusion says that in the world, B is in P. Now, the logical words or symbols in this inference could have meant something different from what they mean. If negation meant affirmation, the inference would not have been valid. But that would not change the fact that in the world there is a connection between at least one X and Y is in P, and X is in the complement of P, and Y is in P. This is a connection in the world. And it is this connection in the world, rather than our linguistic conventions or the language game we happen to play, that is responsible for the logical validity of one. In this way, the logical validity of PA or PB, not PA, therefore PB, is similar in kind to the causal validity of A hit B, therefore B moved. They are due to certain regularities that hold in the world. A causal regularity in the case of 3, a formal regularity in the case of 1. It is for this reason the truth in the world is transmitted from premises to conclusions, both in 1 and in 2. So not only are the sentences of 1 and 3 true or false in the strong sense of being true or false in the world, their inferential power is due to relevant regularities or connections in the world. This is further seen by the fact that no relevant regularities or connections exist in that when no relevant regularities or connections exist in the world, the corresponding inferences are invalid. For example, since in the world there is no regular connection between billiard ball A being stationary and billiard ball B moving, the inference A is stationary, therefore A is moving, is invalid causal inference. Similarly, since in the world there is no connection between 1, at least one of X and Y being in P and X being in P, as you can see here in the picture, and 2, Y being in the complement of P, the inference PA or PB, this is a different from the original, PA, therefore not PB, is not logically valid. It is a game. It could be an inferential game, but it's not valid. There's nothing in the world that connects the two parts. Let us see a case in which accepting an inference like 1 prime, that's PA or PB, PA, therefore not PB, an inference that fails in the world, and acting upon it can bring about death in the world and not just losing a game. Suppose A and B are mushrooms, P means poisonous, and in the world mushroom B is poisonous. This is compatible with the premises of both the valid logical argument, 1, and the invalid game argument 1 prime. PA or PB, at least one is poisonous, and A is not poisonous. We didn't say anything about A, or A is poisonous, being true. But while the game inference 1 prime gives us license to eat mushroom B, it says it's not poisonous, that will kill us, the worldly inference 1 does not. There is a life and death difference between one which is grounded in the world and 1 prime which is grounded in a convention or a game. And the same holds in other cases. Just as using an incorrect aerodynamical laws in building an airplane can cause the airplane to crash, so using incorrect logical laws in designing an airplane can cause it to crash. Once I played a game of creating a logic in which when you give instruction lift, you get drag. When you give drag, you get lift because the logic tells you to do so. Conclusion. Logical inferences, like causal inferences, are based on regularities in the world. Physical regularities in the case of causal inferences, formal regularities in the case of logical inferences. 2. Counterfactual or modal scope. We have seen that logical and causal inferences are similar with respect to truth in the world. Next, let us turn to their counterfactual scope or modal force. Inferences are divided into weak, material, and stronger, non-material. Weak, here we have, we go from premises to conclusion, and there's only very weak requirement. It cannot be the case that all the premises are true and the conclusion is false, where truth means true, actually true in the actual world, no more. No requirement of a regularity in the world that connects the premises to the conclusion. For example, here is an example of a material inference. San Diego is in California, therefore New Haven is in Connecticut. This is materially correct because the consequence, the conclusion is correct, is true, and there's no regularity in the world. That's material inference. Causal and logical inferences are stronger. They require regularity, indeed a strong regularity, one that includes counterfactual cases. Hence, inferences have counterfactual scope. Thus, A hit B, therefore B moved, holds not only for actual billiard balls, but also for counterfactual billiard balls. PA or PB, not PA, therefore PB, holds not just for actual mushrooms, but also for counterfactual mushrooms. Both have counterfactual scope. But do they have the same scope? And if not, why not? I'm not looking for an answer that relies on our intuitions. I usually don't believe in intuitions. I'm looking for a theoretically systematic, precise, informative, and correct answer. To arrive at such an answer, I will turn to invariance. And to make the answer more informative, I will move to new examples. In particular, I would like to use an example of a logical inference that has a richer logical structure, and an example of a causal inference that is related to a general law of nature, such as Newton's law of gravitation. My examples will be 5. For some x, px or not, or qx, for all x not qx, therefore for some x px. Somewhat similar, but we have here quantification. Something is p or q, nothing is q, therefore something is p. 6, some kind of inference from gravity to motion. For example, gravity causes the free fall of objects near the surface of the Earth. I will show that 5, the logical inference, is based on a connection in the world between properties that have maximal degree of invariance. And this means that it itself has a maximal counterfactual scope, and that means that it has a maximal modal force, that is necessity. I will also show that 6, the causal inference, is based on a connection in the world between properties that have non-maximal invariance. Therefore, they have non-maximal, although significant, counterfactual scope, and non-maximal yet significant modal force or necessity. Invariance. Invariance is a central topic of interest both in science and in logic and mathematics. There are many types of invariance. For example, invariance of laws of nature under replacements of frames of reference. Here I will focus on invariance of properties under replacements of individuals. To prevent misunderstanding, let me clarify that I use the term property in its everyday sense, not as a philosophical term of art such as universal, and I'm also not interested in the ontological status of properties here. What I say here is compatible with different ontological accounts of properties. Now, properties in general are selective, and they're selective in nature. They distinguish between some objects, but not all. Example, the property is a human distinguishes between me and my laptop, but not between me and Alex, or between my laptop and the number 1. Neither of them have this property, so it doesn't distinguish between them. The property is a woman does distinguish between me and Alex, but not between me and Priya, or between Alex and the number 1. I will say that is a human is invariant under replacements of me by Alex and of Mount Everest by 1, but not by a replacement of me or Alex by 1 or Everest. In general, a first-level property P is invariant under replacements of individuals that have it by individuals that have it, and by individuals that don't have it by individuals that don't have it, but not by individuals that have it by individuals that don't have it. So this is very general and simple. More precisely, I will talk about invariance of properties under one-to-one replacements of individuals, or if I take domains into account under one-to-one and onto replacements of individuals. For example, in the domains Gila, Alex, and the number 1, one domain, and second, Priya, my laptop, and Mount Everest, is a woman is invariant under the one-to-one and onto replacement R, which goes from me to Priya, and from Alex to my laptop, and from Everest to the number 1, but not under the one-to-one and onto replacement R prime that goes from me to my laptop, from Alex to 1, and from Everest to Priya. That is only replacement that lead us from things that are women to things that are women, or things that are not women to things that are not women. Now we are ready to proceed to maximal invariance. Maximal invariance. While the properties we looked at so far are invariant under some, the properties Okay, while the properties we looked at so far are invariant under some one-to-one and onto replacements, they are not invariant under all. But some properties are invariant under all one-to-one and onto replacements of individuals. These properties are maximally invariant. Example, is identical to. Take any individuals A, B, and replace them by any individuals in a one-to-one manner. You replace A by RA and B by RB. It is easy to see that identity is preserved. A is identical to B if and only if RA is identical to RB. If we have equinumerous domains, this holds across domains where R is one-to-one and onto. So identity is maximally invariant. The second level property, non-emptiness, or non-empty, is also maximally invariant. This property is the property denoted by the existential quantifier. When we say for some x px, what we say is that the property P is not empty. So the denotation of the existential quantifier is the second level property is non-empty. Now take any two equinumerous domains, D1 and D2. Take any one-to-one and onto replacement R from D1 to D2. Take any first level property P and D1 and look at the image of P prime under R. It is easy to see that P is non-empty in D1 if and only if its image under a one-to-one replacements of the individuals is non-empty in D2. So is non-empty is also maximally invariant. And we have the result, 1, all the logical properties, that is, those that are denoted by the logical constants, such as identity, a complementation in a given domain denoted by negation in a context like Px, intersection, union, inclusion, non-emptiness, and universality in a given domain, they are all maximally invariant. Second result, no physical properties are maximally invariant. One way to see that is to note that they are not invariant under one-to-one and onto replacements of physical individuals by mathematical individuals, for example, numbers. All physical individuals are subject to gravity, but numbers are not, and similarly for all other physical properties. Next result, maximal invariance entails large counterfactual scope, which entails strong necessity. Maximal invariance of property entails stronger counterfactual scope of inferences based on them than of inferences based on non-maximally invariant properties. It follows from this result counterfactual scope of logical inferences is greater than the counterfactual scope of causal inferences. But the difference between them is only a matter of degree. Now let me explain this or show that this is the case. Let us first explain this result by means of an example and then theoretically. The logical inference we had before for some x, px, or qx, for all x not qx, therefore for some x, px, is logically valid because in the world, the non-emptiness, existential quantifier, of the union, disjunction, of two properties, and the emptiness of the second for all x naught, is connected by a formal regularity to the non-emptiness of the first property. Now, this holds in all actual counterfactual domains of individuals, that is, in all domains of either actual or counterfactual individuals. Therefore, the counterfactual scope of this inference, hence its modal scope, is very high. Another way to represent this, on the level of the world, the lowest level, where we look at actual and counterfactual individuals, we have a regularity, a formal regularity or law, non-emptiness of the union of P and Q, and emptiness of Q guarantees or brings about or necessitates non-emptiness of P. This ensures that on the level of truth, the truth of the two premises guarantees the truth of the conclusion, and this guarantees that the inference for some x px or qx for all x not qx, therefore for some x px, is logically valid. This explains why the above inference transmits truth from premises to conclusions and does so with a strong necessity. A note on the scope of maximally invariant properties and inferences based on them. Logical or formal properties do not distinguish between individuals that are physically possible and physically impossible. From their point of view, there's no difference between them. And even between individuals that are metaphysically possible and metaphysically impossible. Example, from a formal or logical perspective, a ball that is both all red and blue is just as possible and just as subject to formal and logical regularities as a ball that is both all red and small. From the point of view of the logical properties, there's no difference between being all red and blue and being all red and small. It simply doesn't, it abstracts from all such differences. Therefore, the counterfactual scope of logical inferences includes individuals that are both all red and all blue, all red and blue. This is not the case for causal inferences, which are based on connections that apply to domains of actual counterfactual physical individuals, but not to other kinds of individuals. Question: but how exactly is maximal invariance connected to maximal necessity? Answer: if a property does not distinguish between two individuals, the laws or regularities governing or describing it cannot distinguish between them either. Otherwise, it will not be a law or regularity of this property. They apply to one if and only if they apply to the other. Now, if P is a maximally invariant property, it does not distinguish between any individuals, actual or counterfactuals, where the scope of counterfactual is broader than physical counterfactuality. Therefore, the scope of the laws or regularities governing describing P is also broader than the scope of physical laws or regularities, and the inferences based on them are also very strong. Now, what about causal inferences and the laws, regularities grounding them? Take the inferences from gravity to motion that we mentioned earlier. While the property is subject to gravity, some gravity, greater or smaller, is not maximally invariant in the actual counterfactual sphere associated with logical and formal properties, it is maximally invariant in the smaller actual counterfactual sphere of physically possible individuals. All physical individuals, actual and counterfactual, are subject to gravity. In contrast, the property is a human or is a Homo sapiens, is not maximally invariant in the physical sphere. For that reason, inferences grounded in laws of regularity governing or describing gravity have a stronger counterfactual scope than inferences grounded in laws of regularity governing or describing humanity, but weaker than logical inferences, which are grounded in formal or logical laws and regularities. So logical inference are strongest, maximal invariance, maximally necessary. Physical inferences and physical laws have a lower degree of invariance, lower degree of necessity, but they can still have a significant degree of necessity such that the laws of gravity or inferences based on these regularities and others too can have some counterfactual scope, but a smaller one. Conclusion. Both logical and causal or physical inferences are grounded in certain laws, regularities that hold of some actual counterfactual individuals. Therefore, both have a certain modal force. But due to the fact that logical inferences are grounded in laws or regularities that govern or describe maximally invariant properties, while causal inferences are grounded in laws, regularities that govern or describe non-maximally invariant properties, the counterfactual, hence modal scope of logical inferences is greater than that of causal inferences. Thank you.
We have time for some questions. If there are questions from people who haven't asked yet, I'll take those first. If not, please, and then.
Yes, thank you very much. I was wondering if you could say something more about the counterfactual mushroom as an example.
Okay. The counterfactual, let me give you sort of another example. I happen to have 2 children. Now, I could have had 3. And I could have said, and there is a sense in which it is true to say, that my third counterfactual, the person who is the third counterfactual child, is a counterfactual child of mine. I think that in general, when we talk, and we always talk about counterfactual situations and counterfactual object, counterfactual things. Should I build this machine or that machine? If I build this one and not this is a counterfactual machine that maybe I could have built. Now, I think that it's very important to understand, to take into account counterfactual objects when you want to understand properties. Why? First, for some properties, they have different degrees of invariance. They distinguish between different things, and so there are differences. This is a significant difference between them. But in the actual world, they may not. I think Quine likes the example of has a heart and has a kidney or something like this. It just so happens that in the actual world, if we take into account only actual individuals, they have the same invariances. But if you want to understand the difference between them, you have to go beyond it. But even more than that, if you take a property of gravity, for example, in order to understand gravity, we have to understand that had Earth had another moon, a counterfactual moon, it would also be subject to gravity by Earth. And we cannot understand gravity, I think, well if we don't understand that. And so in general, in order to understand properties, and then the laws that govern them, we have to understand how they would behave if something that is not the case were the case. So that's where I get to counterfactual objects and including a counterfactual mushroom.
Naftali first and then Stephen.
Yeah,
So
hi.
in my everyday experience and at the experience of people I know, quite often inferences come after a delay. You look at work on something, think about something, nothing works. You wake up in the morning, brush your teeth, and here's an answer. What mechanism does it involve? It's clearly not causal or it's not language related. What mechanism involves there? And a broader question, I mean, I appreciate this logic, it's all logical, but what kind of mechanisms humans use to come up with inferences?
Okay, yeah, so I think both the questions you asked are, for me, they are connected.
Yes.
I think that knowledge in general depends both on how the world is and on how our mind works. We can only know the world through the prism of our mind, of our cognitive resources. And so, in the case of inferences that you talked about, as a result of undergoing this complex situation in which we both look in the world and use all our cognitive resources and come to know the world better and better, we can see connections between things in the world. And it is seeing the connection between different things in the world that lead us to make inferences about this subject matter. Sometimes the connection we see are formal, and then the inferences will be logical or mathematical. Sometimes the connection we'll see is like a connection between taking aspirin and fever going down, and then we will realize that in the world there's a connection between certain components of these two phenomena, and we draw an inference. And so generally, I think when we look at going to your second question, how do we get to inferences? So the way I look at it is this. I mean, human wants to know the world as it is, but we have many limitations. We make mistakes, our cognitive capacities are limited, so we need something that distinguishes between correctness and incorrectness. So we introduce the concept of truth. And we also have limited time. We cannot always just establish individually every statement we want to establish, so we look for shortcuts, and inferences are shortcuts. In inferences, it's enough to establish the premise and establish the connection to other things, and then you get the conclusion, and you don't have to examine it separately. And I think that humans have the ability to detect formal regularities in the world. For example, they can see, if you take some physical properties, some properties are reflexive. That's a formal feature of a property. Some are symmetric, some are transitive, some are not. And you can see that if you have a property which is transitive, it doesn't have to be symmetric. But if you have a property which is both symmetric and reflexive, and the universe is limited, you can get transitivity. And so we can figure out formal connections between properties. We can figure out cardinality connections. We can say that for example, the cardinality of people in this room is maybe, 30, 40, something like this, not 0, not 100, and we can draw connections between 40 and cardinality 20 and say that the first is larger than the second, and so on. And so we observe regularities in the world, including formal regularities, and I think that's how we get to logical inferences. And we observe regularities in general, or connections in general, and that's how we get to other kinds of inferences.
We can take one where Naftali was first, and then we will need to stop but those of you who want to stay and talk a little bit more, we have time before dinner. Naftali, then we'll thank the speaker. And just
Great. Yes, thanks so much for your talk. So I like the notion of maximal invariance, but I'm still having a really hard time wrapping my head around formal regularities. And especially the notion of formal regularities being something in the world. And maybe one way to put the thing that I'm sort of a bit bothered by is you might think that actually maximum invariance would actually count against formal regularities being in the world. I mean, the thought just being is that if these logical truths could apply to a totally fictional world or even a world that's, I mean, it sort of seems to take away from the notion that these are actually in the world in some sense. So I don't know if I'm just begging the question and, adopting what would take to be the more traditional view about logical truths being true in virtue of form, but it still attracts me, and maybe you could help me.
Okay, so first let me say something about formal regularities in the world. First, perhaps I will mention another result, which is an interesting result, not obvious. It turns out that all higher level mathematical properties are maximally invariant, but aside from identity and a few others, all first order, lower level mathematical properties and mathematical individuals are not maximally invariant. Now, this is relevant to how we think about the formal. Today, we very often think about the formal, the mathematical, as first level. And we think about individuals, 1, 2, 3, and we can say, well, we have no evidence for their being in the world, and so we need to be Platonist in order to accept that, and we don't want it. Let's just go with the linguistic interpretation of mathematics and logic and so on. But now what I'm talking about is mostly properties of properties. Even if you start just with physical individuals, you are Humean, and even you start just with their physical properties, it is a fact that in the same way that in this room has the feature that there are men in it and women in it, they also has the feature that there are 40 humans in it rather than 1 million or 0. It's just a fact, and it's a formal fact about the situation. It is a formal fact about the relation of X sits next to Y, that this relation, which is instantiated in this world, in this room, is symmetric but not transitive. So it is sort of, there are formal facts. They are not on the level of individual numbers and their properties. They are at the level of largely second and higher level properties of physical and other properties. Now, how do you reconcile this higher level formality with the fact that we do mathematics, usually first level in terms of individuals like numbers? My own explanation is, and this is part of what I said before, how we know the world depends on our mind and on the world. It is very likely that human beings are such that it's easier for them to figure out relations between, say, cardinality properties when they think about them in terms of structures of individuals and their properties, numbers and their properties, rather than properties of properties of properties. That will explain why we talk in terms of first-order terms, which is very different to connect them really to reality. But they are systematically correlated to this higher level terms, formal terms, that it's very easy to connect them to reality. So that's how I sort of think that the formal is in the world. And I'll just say one more sentence, that even if you take the physical, I mean, gravity is in the world, even though it has certain counterfactual scope. So just because it holds of counterfactual physical object doesn't mean that it's not in the world. I don't think about counterfactual situations as other worlds or possible worlds. It's a way to represent to ourselves a certain force and a certain stability and generality that some properties have. So that's how I look at it.
Anyway, let's say thank you so much.
Thank you.